Alright, so in the warm-ups, we were looking at the volume of a cylinder, and you guys looked up the formula on your green sheet, and it was pi r squared h. Well, today what we're going to be doing is looking at how do things change with a cylinder. Like as water comes out of the cylinder, changing the volume, how does that affect the height? Okay, so let's take the derivative. What's the derivative of v with respect to t? dv dt, right? Now, right here, r is a variable and h is a variable. So therefore, this is going to be the first part, and this is going to be the second. Or we can think of this as f and this is g. Because we have this, we're going to have to use the product rule. So we'd have to do derivative of the first, f prime, times g plus f, g prime. So what is the derivative of the first? 2 pi r. What would I have to put out after that, though? dr dt, good. So that's derivative of the first, that's f prime, times g plus f. And then what's g prime going to be? Just dh dt, right? Okay, so then just simplifying this a little bit, we have dv dt is equal to 2 pi r h dr dt plus pi r squared dh dt. But I want you to think about a cylinder. Okay, so if we have a cylinder, right here's a cylinder. If we have something where, let's say that fluid is coming out of this, that we've got water running out of the bottom of it, is the height going to change? As water comes out of this, is the height going to change? The height of the water? Yeah, the height of the water is going to change. Is the volume of the water going to change? Is the radius of the water going to change? No. So therefore, in this formula, dr dt is always going to be 0. So if this is 0, what's going to happen to this entire term? It's just going to disappear, isn't it? So really, when we go to use the formula for the volume of the cylinder, all we're going to have to use is pi r squared dh dt. Okay? And that brings us to our notes. So looking at our notes, that's what that says. It says, here's the formula for the derivative, but you have to remember that the RDT is always going to be 0. So let's do a problem with a cylinder. A large cylindrical can with a radius of 10 inches and a height of 40 inches is losing water. The height of the water in the can is decreasing at a rate of 0.25 inches per second. At what rate is the volume of the can decreasing? So we're going to write down our formula, which is this right here. However, we know dr dt is going to be 0 always, so we're just going to use dv dt equals pi r squared dh dt. So you should always read the problem first, not any kind of word problem. Now you go back and substitute in. The radius is 10. Plug it in. 10 squared is 100 pi. Height is 40. Do I need to use that information? No. Sometimes there's going to be extra material in the problem or extra information that you don't really need to use. The height of the water in the can is decreasing. That means it needs to be negative 0.25. I can call that dv dt. I can also call it v prime if I want. It says to get the answer to the nearest tenth, so we're going to have 100 pi times negative 0.25, and we get negative 78.5. Now watch how I write the answer though. V prime is 78.5 cubic inches per second. I did not put the negative there. You may know why I didn't put the negative there. The question says, at what rate is the volume of the can decreasing? It's a little redundant to ask that question and then put a negative. You see what I mean? If it had said, at what rate is the volume of the can changing, then we would either need to have the negative or we would need to say the word decreasing. So you have to read carefully to be able to answer it correctly. All right, number 2. A boat is being pulled toward a dock by a rope attached to its bow. through a pulley on a dock 7 feet above the water. If the rope is hauled in at a rate of 4 feet per second, how fast is the boat approaching the dock when 25 feet of rope is out? Okay, so again, we're going to draw a picture here. Got the water, got this pulley up here, we've got the boat in the water. So here's our picture. So we first want to think about what formula we're going to use. Obviously this has nothing to do with the cylinder. This would be our x, this would be our y, this would be our hypotenuse of that triangle. This would be a right angle. So we know we're going to use that formula that we talked about a minute ago. Well, we didn't actually get to this one, but for the Pythagorean theorem, we have x squared plus y squared equals h squared. So taking that derivative, it's going to be 2x dx dt plus 2y dy dt equals 2h dh dt. So how did I go from here to saying we can just use this one? What did they do? Yeah, just divide each term by 2. It's still equivalent. Okay, so we can use this formula then. So I'm going to write that formula down. We're doing x dx dt plus y dy dt equals h dh dt. So first I'm going to figure out what it is I'm trying to find. If the rope is hauled in at a rate of 4 feet per second, how fast is the boat approaching the dock? The boat approaching the dock. Here's the path of the boat approaching the dock. The boat is not going to come up out of the water. The boat stays in the water as this gets reeled in. So what is it I'm trying to find? Dx dt, right. So this is what I'm solving for. In order to solve for that, I have to know x, y, dy dt, h, and dh dt. I have to know everything else. So I go back and read the problem. Boat is being pulled in, pulley on a dock 7 feet above the water. Where's that 7 going to go? What is it, guys? X, y, or h? Y. So y is going to be 7. All right, that's a good start. Rope is hauled in at a rate of 4 feet per second. What is that going to be? Think about where the rope is. Is the rope on y, x, or h? H is the rope. Okay, so what's it going to be? It's not going to be that h is 4. What's going to be 4? dh dt. So dh dt. In fact, it's going to have to be -4 because it's getting shorter. I have to make sure that I do that when I'm doing the problem. Okay, let's keep going. How fast is the boat approaching the dock when 25 feet of rope is out? Where's the 25 going? X or H? H is going to be 25. So again, I have to know everything else. I've got this covered. I've got H and dH dt. I've got Y. I need to know dy dt. Does anyone know what dy dt is going to be? What's that? It stays the same. So what's the change in it going to be then? 0. So dy dt then should be 0. See, if something doesn't change at all, the change in it is 0. So we've got that. So let's see what we need. We need one more thing. We need to know what x is. Does anyone know it? How do we find it? Pythagorean theorem. I can do x squared plus y squared equals h squared. X squared plus 49 equals 625. X squared, subtract the 49 from 625. 576, take the square root, 24. Guys, if you can memorize the Pythagorean triples, you can save yourself some time. This is a Pythagorean triple, but some people didn't recognize that it was. One of the Pythagorean triples is 3, 4, 5. This one we just found, 7, 24, 25. Does anybody know any other ones? What's that? 5, 12, 13, yep. And then there's another one that goes 8, 15, 17. So these are some Pythagorean triples that will save you time in these problems. Because if you know 3, 4, 5 is a triple, so is 6, 8, 10, 9, 12, 15. Let's multiply them by 10. 30, 40, 50. All of those are going to be Pythagorean triples too. 70, 240, 250. Okay, saves us time. All right, so now let's go ahead and substitute in. We've got x is 24, dx dt is what we're solving for. Y is 7, dy dt is 0. 25 for h, negative 4. So we're going to have 24. I'm just going to call this x prime now. 25 times negative 4 is negative 100. Divide it. And x prime, which is also dx dt, 4.17. And that's going to be feet per second. And I'm not going to call it a negative, because why is it a negative? Why did it end up being a negative? What's happening to that distance right there? It's getting shorter. It's not that the speed is slowing down. That's what sometimes people think. It's slowing down. Actually, it doesn't slow down. It speeds up as it gets closer and closer. The reason that that answer was negative is because this distance is getting shorter. Guys, another thing I noticed is that people don't have any concept of what that means. That 4 feet per second. I mean, people don't know, is that fast, slow? What is that? You know, we're used to using miles per hour, aren't we? How can I convert 4 feet per second into miles per hour? Anybody know? I want to get a mile. Instead of having feet, I want to get a mile. Well, I don't really want to multiply. I have to divide by it. The reason why is because I want the feet to cancel out. So if I do that, now my feet will cancel, so I'm really just multiplying by 1. Another thing I want to get rid of is seconds, because I want to end up with miles per hour. See, right now the feet cancel. Right now I'd have miles per second if I divided by 5280. So if I want to get 1 hour, how many seconds would that be? Right, 3,600. So 3,600 seconds, and so these would now cancel, and now I'd be left with miles per hour. That conversion like that, it's probably the easiest way to do it, because, you know, you think, do I multiply or do I divide by 5280? Do I multiply or divide by 3,600? If you set it up like this, you'll always be correct. So another name for that speed that they gave us, it sounds fast, 4 feet per second, but actually when we figure it out, it's only like 2.7 miles per hour. It's really slow. Okay. So if somebody says, oh, I can run 4 feet per second, yeah, that's not fast, actually. Okay, number 3. An airplane is flying at an altitude of 3 miles on a flight path that will take it directly over a radar tracking station. If the distance between the station and the plane is decreasing at a rate of 300 miles per hour, when the distance between them is 5 miles, what is the speed of the plane? All right, so again, we need a picture. So we have an airplane up in the sky. I am a horrible artist. I'm going to try to draw an airplane. Here's the wings. I don't know, that doesn't look like an airplane, but that's my airplane. Kind of looks like a fish, but that's okay. All right, so here's our tracking station. Okay, the airplane is at an altitude of 3 miles. So altitude means what? Yeah, it's height up in the air. So this is going to be 3. This is my y value, that's 3. On a flight path that will take it directly over a radar tracking station. So the airplane's flying directly like this. It's going to go right over top of that station. Let's keep reading. The distance between the station and the plane is decreasing. So here's the distance between, look at this again, here's the station, here's the plane. This distance, which that's going to be the hypotenuse of my triangle, so that's going to be dh dt. What should I call it if it's decreasing at a rate of 300? Negative 300. Let's go through again. When the distance between them is 5 miles. What are they telling me is 5 miles? Is it the y, the x, or the h? The distance between them. What is it? H, right. So h is going to be 5. Okay, when the distance is 5, what is the speed of the plane? Well, the speed of the plane, that's going to be this change right here. That's going to be the same as this change down here, right? So I can think of dx dt as either being this path or this path. It's going to be the same thing. So dx dt is what I'm trying to find. That's the speed of the plane. So our formula, x dx dt plus y dy dt equals h dh dt. Okay, so we need more information, guys. We're trying to solve for dx dt. Does anyone know anything else? Okay, I heard x has to be 4. Does everybody agree x is 4 because it's a Pythagorean triple? Lindsay just said that dy dt needs to be 0. Do we agree with that? Yeah, this isn't going to change, is it? The only way this would change is if the plane was going downward. That wouldn't be good for those people in the radar station. The plane's going this way, right? So dy dt is not changing. It's staying at the same altitude. All right, so now we're going to substitute everything in. We've got x is 4. Dx dt is what we're solving for. Y is 3. Dy dt is 0. H is 5. And dh dt is negative 300. So we have 4 dx dt equals negative 1500. Figure that out. 1500 divided by 4, 375. The question's asking me what's the speed of the plane. Speed is 375 miles per hour. It doesn't make sense to call it a negative speed. We never use negative speed as a final answer. We might use negative within the problem, but if I asked you what's the speed of that plane, you would never say it's a negative speed. The negative just occurs because the plane is getting closer to the station. This x value is getting shorter. Okay? All right, any questions? Okay, so those are the two formulas you're going to be focusing on today. Those are the two new ones. Volume of the cylinder right there. Remember that dr dt is always going to be 0 in that one. Pythagorean theorem, we showed how this derivative came about, and we can divide that one by 2 to get the one that's even a little bit easier to work with.